So this is some DMTA spectra on these composites. Basically, this is a blend 50-50 PLA Ecoflex with 50% wood and 20% wood. Some results, probably if you're familiar with PLA, you know that it has a TG at about 60 degrees, and there is a big drop in modulus, and that's why it's a main problem of PLA at the moment, because there are lots of applications where this is too low, the temperature, the heat resistance is too low. And we see here that by adding wood fibers, we increase the heat resistance. In fact, the drop in modulus about 3 to 4 order of magnitude at TG. So it's really completely loss of property. Then the material crystallizes. You know, if you can see here, we have a drop in modulus, and then here the modulus starts to go up again. This is crystallization, but of course it's not doable under industrial condition, because crystallization is very long. So we tried with an industrial injection molding machine, and you need some nucleons to try to accelerate the crystallization, but still you need about 90 degrees for the mold, and about 2 minutes of injection molding time. So really it's not practical. So we cannot crystallize the material. It has to be amorphous. You know? But with fibers, you see here that with 20% fibers, the drop in modulus is very low. So this is, I think, an interesting result that we got from this work. And also we did some work also on PHB and PEG, and we obtained some PHB from Biomer, which is a company in the Industrial Advisory Board. And they have their own formulation, which is very good, in fact. But we tried pure PHB and tried to modify with PEG. And we found that it's not an easy task, because PHB, in fact, pure is very brittle. It's a very brittle material. And even with PEG, the properties improve very little compared to PLA. So PHB is I mean, why PLA is so successful at the moment, because it's easy to be modified and to obtain a better material suitable for application, while PHB is much more difficult to work. And unless you rely on formulation from a private company that you don't know exactly what's inside. So we found... So this is a comparison of PLA Ecoflex 50-50 and 20-80 blend, also PHB, with 15% wood fibers. We considered basically two types. Retemaire is more expensive and better aspect ratio, but Lazzeri is just an Italian company providing wood flour. And we see that the difference in properties is probably not so significant to justify the higher price of the retemaire fiber. We also tested the acetylated fibers. We saw that the properties are also good enough, although the price of acetylation is still questionable. No? Sorry about a little bit of cough due to the weather this last 2 weeks. So also this is another comparison between 20 and 30% fibers. We mainly focus on retemaire, which is a best property, gives us slightly best properties, and we see that can get material with a high modulus, with starting from 50-50 PLA Ecoflex. And still some ductility. For example, the blend 50-50 has still 6% elongation. Instead, the blends with PHB are still very brittle, 0.5, 0.6%. You know, so, and also the tensile strength of the PLA Ecoflex 50-50 is good enough, 42 megapascal. So we could go to some application. This, again, is a PHB, but I told you that we got some not very good results because the material remains quite brittle even by addition of PEG. We tried also some other type of coating on the fibers, not just acetylation. We use some paraffinic wax, and on polypropylene composite we improve the dispersion, and also some mechanical properties that you can see were improved. Also, we tested some PHB. This is not the pure PHB. This is a commercial product from Biomer because we found that the blend we could do with PEG were not good enough. But this product is a commercial product. P226 is in fact a commercial product from Biomer, which have good properties. So we could use some wood fibers in it, and with a good result. I cannot go too much in detail because time is running, and maybe if you are interested, I can give you details later. So also we skip this because it's a bit far. Okay, some application we produce as during the project. You see, the tomato yarn are in based on PLA Ecoflex with 20% PLA, 80% Ecoflex. Very soft material, so we could add up to 20% fibers and maintain some ductility. And this is for application for tomatoes plants to stick them to stay them stable, no? And so we can make a knit with them. Also, we for pots we use the same composition, 20-80 PLA Ecoflex, because for injection molding application, when we add 20% fibers, the other formulation were too brittle. This instead was quite good. Also, other type of packaging, we have a cosmetic box for cosmetics. This is made on PLA Ecoflex 50-50 with retamine fibers, and also trays for food. No? So this is made by the same formulation. Also, just going to the end of my presentation, we're finishing with Forbioplast in a few months, and we are starting now new projects which are somehow based on ideas that we developed in Forbioplast. This Oli PHA is a small-scale project which will start in probably January, and it's based on the production of PHA from olive oil wastewaters. And also another project which is probably starting in the same period is Biocompack, a development of injection and blow molding biodegradable and multifunctional packages by nanotechnologies, which is also based on PLA and our experience on PLA. Just finishing, I would like to invite you to a major conference we are organizing within Forbioplast, and also in collaboration with other FP7 projects like Woody and Biostruct. And this will be in May of next year in Sea of Folk on Lake Balaton. It's a very nice place, and I would like to invite you to visit our website. We have a program, and I have here some leaflets I can give you after the break. Also, okay, this is general conclusions that we expect from the project, and this is thank you for your attention.